Welcome to the Z-Hut's Mad Scientist Laboratory. I'm Professor Z, and today we're going to attempt to take over the world using Arduinos. Grab your favorite Arduino board and put on your tinfoil hat, because it's time to build. Today, we will be attempting to take over the world by building a kitty cat laser tower toy. First, we will take a look at building the base and the tower, and then we will take a look at the laser and everything that makes it work. So here's a quick demonstration of it, and make sure to stay till the end of the video, or I will put this on the floor and let my mad scientist evil cats play with it and demonstrate it working. As you can see, it randomly moves and points the laser at the ground, which makes a nice toy for the kitty cats. All right, to build this, for the base, I just used a piece of wood, and it was some scrap wood. I cut it in half, screwed it together, made the perfect base. Then to attach, we're using a 3-inch PVC pipe to attach it to the board. We're using one of these. The exact name of it, I am not sure. But when you look in the plumbing department, you can ask, this is what goes on the floor in your bathroom. Then the wax ring goes on it and the toilet bolts to it. This is what you want, and you want it to fit a 3-inch pipe. I don't know if they make them to fit 4-inch. 4-inch, you go with one size pipe, but this is a little more inexpensive by using the 3-inch pipe, is cheaper than the 4-inch pipe. Then I'm using, this is about a little over 2 feet of 3-inch PVC pipe, and nothing is glued except, I'll show you when we look at the head, there's one part there that's glued. So this will all come apart so you can store it. And it's about a little over 2 feet, maybe 2.5. I would recommend 4 foot. It will work better. I just simply had this piece on hand. It was the longest I had. I have a couple of these. I will be, in the future, lengthening this, making it taller. Leaving it short like this also worked good for the video. It would all fit on screen at once. Then for the head, up here, and we will take a closer look at it in a moment, but there is an end cap, and this is called a test end cap, and this is for 3-inch, and it fits on the inside of the PVC pipe. Then for the 4-inch, we're using, this is about 2.5 to 3 inches, a 4-inch pipe, and then we need two end caps, and the ones that go over and cover over. They don't fit on the inside, they fit over the pipe. The ones that fit on the inside will not work for this project. With that, one more thing. I have a power plug on the bottom of the pole. I didn't put it on the base, that way we could take and separate it. And I've got a wall wart on the floor, plugged into a power strip. And there's a corresponding power plug on the back, and that plugs into it. All right, with that, let's go over to the workbench by the computer, and I will take this down, and then we will be able to zoom the camera in, because right now as it is, it would be kind of hard to show you how the laser and the servos and everything that control this are mounted. So I'll catch you there in just a second. All right, I've removed the tower from the base so we can take a closer look at it. First, I would like to show you a closer look of how the 3-inch pipe is joined to the 4-inch. And this is the test cap I was talking about. This is a 3-inch knockout test cap. It fits on the inside of the pipe, where on the 4-inch pipe, the enclosure for the laser device uses the fit over test caps. I simply centered it, then used PVC glue and glued the two caps together. Otherwise, it is removable. Because of the paint, it's a little stiff, so I'm not going to try to pry it apart. But I also drilled a hole through there big enough to feed the wire through, and I left enough extra wire so that the head could be taken out and set down, and so you can work on this. So I'm going to move over a little. Now, for the build of the enclosure for the laser device and laser device itself, the arm that randomly points the laser. We'll look at the arm first. What I have here is 1/2-inch PVC pipe, and on this piece, you can see the laser is just hot glue gun in there. The wires run out, and I have a hole in this, the first arm here, that the wires can go through, and then to our test cap, we have a hole there as well for the wires from everything, for the servos and the laser to run through. And this is just screwed on. You can see what servo head I used. It's just the one that points and has a couple holes, and I just found some small screws. Used my rotary tool with a real small drill bit, pre-drilled it, put them in there. This piece is just a little over 1 inch long. It was a piece of scrap I had left over, so it is a little more than 1 inch. You only need this to be long enough for the laser device to fit in. But I do recommend going, at least 1 inch. This is maybe 1.5 inches. 1.5 to 2 inches will work fine. I would not go over 2 inches, and I would try not to go under 1 inch. Now, I did not have the screw. I do have a screw, so I can screw this together. I do recommend screwing it together. What we have here is one of those micro servos. And as you can see, I have a regular size servo here. You can use micro servos for both. I just only had one of these micro servos on hand, and I had a couple of these large ones, and I did not want to use a regular servo down here. The micro servo works great because with the 1/2-inch PVC pipe, I once again took my rotary tool, used a cutoff disc, cut a slot out that allows the servo to sit in, then drilled 2 holes that were slightly smaller than the screws I was going to use to attach it. And then it sits in there, so it sits inside. I would not recommend using anything larger than the 1/2-inch pipe. Unless you are stuck, you only have 2 of these normal size servos, you would probably have to go, I would think, 3/4 inch. You would possibly be big enough for you to make an enclosure for the servo, but most likely not. So I do recommend, and you can get these if you buy a few of them at a time, and you get them from China or places like that. You can get them for around $1 each. So, like I said, I recommend those, but if you have only one, and like me, and then have some regulars, do it that way. Otherwise, if you have no servos and you're ordering the parts, get 2 of the micro servos. Now for the connection back here, I will go ahead. Once again, I have not screwed this down yet. I just took and put it at an angle. So this is to the side, and then this is straight up and down. Drilled 2 small holes that were just smaller than the screws I used once again. Then I made a bigger hole that runs all the way through and runs to the top of this servo head here. This allows you to do is to fit. You want it big enough to fit your screwdriver and the screw that you were going to use to attach this to. You could probably get away without putting screws on it, but I am going to be keeping this. I am not going to take it apart and repurpose it for another tutorial. My cats really do like to play with this. Now, next, once again, I just took, and I'll pull that back off, I took my rotary tool, a Dremel tool, and I cut out for the servo to fit on the cap. I decided to put it close to the edge. Just make sure you don't put it too close to where the cap will not fit on. And then I drilled holes and secured it with a couple small screws and nuts, or bolts and nuts. And then, like I said, all the wires run through a hole I made here. And I use my rotary tool, and it was kind of like a milling bit for it. And I made an oblong hole because the servo connectors and other things I have need to be, I didn't want to make a huge hole, I just wanted it so everything would just barely fit through. Let's go ahead, open, oh, one more thing before I open it up. The power switch is on the very back side. That way you can leave this plugged in and you just, it's on or it's off. Open it up. I'm going to disconnect positive and negative. That will allow me to remove all the insides. And there you can see the inside. There's the switch. And I just ran the positive side through the switch. And the negative goes right to the ground on the Arduino board. So I can move this out of the way. For the Arduino board, I recommend for this, now you could use an Uno, Nano, you could use pretty much whatever you had on hand, but I do recommend one of these. It's an old DeMillinovi board. It's an older Arduino, and I am not sure, I haven't looked, but you might be able to find an Uno that has it as well, but it has pins on here, plugs that correspond with the same pins that you would connect your servo to, that has the positive, the ground, and then the signal wire. So instead of having to use the jumper wires through there and plug in individual pins, you can just plug the servo directly onto the board. As you can see over here, it has some more pins for like attaching sensors. It's a very handy board. I only have one of these. I have quite a few Unos, Nanos, and I have a Mega. This one I primarily use just when I'm playing with servos, but now that I've built this, I will be ordering another because I am going to dedicate this to this item. Like I said, my cats like it. I am not going to bother making up a schematic for how this goes together. It's simple. You got a ground and power wire for the laser, and I just put that to the 5-volt pin and the ground pin on the Arduino board. And then I plug the two sensors, or excuse me, the two servos and two pins, and they correspond with digital pin 3 and 5 on the Arduino board. And it has pin 3, 5, 6, 9, 10, and 11. And those are most likely, I do believe that is all the PWM pins on the Arduino DeMillinovi board. I will have a link on the website. I will try to find on one of the places I order stuff from, I'll put a link so you can find where you can get one of these. Like I said, you can use a normal Arduino board. All right, with that, I will also try to take some close-up pictures of this and put it on the website. But next, let's go over to the computer and look at the Arduino code that controls this. And for those pictures and other stuff, also the Arduino code we're going to be looking at in just a second here. Just look in the description below. You'll find a link to this project's webpage. So I'm going to get the computer turned on and I'll catch you there in just a second. All right, I've got the Arduino sketch brought up here. So let's just get right into it. First, we're going to need to include our servo library, and that is already built into your Arduino IDE, so you don't have to worry about downloading it. Then we're going to set up two servos, and we're just going to call them S1 for servo 1, S2 for servo 2. Then we're going to set up some integers here. First is going to be the S1 position, and then the second is going to be the S2 position. And this is what we're going to use down when we get to the random, selecting the random numbers. This will be the integer that that random number is put into and then written to one of the servos. Next, we have some more integers, and we got the S1 low and the S1 high. That's for the first servo. And what this is doing is setting the minimum and maximum angle of the servo. I do not like to set my servos all the way from the 0, the minimum, to the 180. I like to have a little play. And for servo 1, and that's the one that's going to sweep side to side, I went with 10 to 170. Now, for the second servo, and that's the one that goes up and down, we don't want the thing to be pointing at the ceiling. We want to keep it towards the floor. So I have here, I figured out, now you're gonna maybe want to play with this just a little bit, but not too much. I have the low angle of 95 and the high of 150. That works for me. You might want to try changing these around just a little bit. And it depends on the height of your tower, but this is a good reference and a good starting point. Then I have here for delay, and that's so you can play with this as well instead of having to go through and change the delays. This is how long it'll wait between movements. And that's the short, and then we have the maximum, which we're going from 100 to 1,000. So we're going up to a maximum of 1 second. Then we have our integer delay. And that's, again, we're using a random number and we're selecting between that 100 and 1,000, and that'll determine how long between, the movements. We're using lots of randoms in here, and that gives it the ability so it's not just following the exact same path all the time. Although the random in the Arduino IDE is not the greatest, but what I have done, and when we get down to it here, I'll show you, I did help to create a little more randomness by adding some extra stuff, but we'll get to that in a moment. So in the setup here, we're attaching our two servos. I'm using pin 3 for servo 1 and pin 5 for servo 2. If you change the pins, change the numbers here. This little bit of code here is for when you were first building this. What it'll do is you uncomment this, and it will set for a minute. It will keep the servos, both of them, at 90, which is halfway in between. That way you can put your arms on and get them positioned where you want them, and you'll know where the 90 and 90 is. And then after you have that set, and I gave you a minute, which should be enough time, you just comment this out, and you probably don't need to leave it in there. You could delete it, but it's not really going to take up any room. So I would just leave it. All right, let's move down here, and I'll scroll through it real quick and show you. This is my little attempt to make it a little more random. I'm just going to go through the first couple of them. What it is I just copied, and I'll explain that right now. I copied and pasted, but I put them in a randomized order of movements. So it's not just servo 1 moving, then servo 2 moving, then servo 1 moving, then servo 2 moving. So you can see I have servo 1 here goes first, and servo 2 will move after that. But then here again, servo 2 will change position again. Then it'll go to servo 1. Then it'll go back to servo 2 will move. Then it goes to servo 1. Then it goes to servo 2. Then it goes to servo 2. And then once again it goes to servo 2. Then it goes to servo 1. Then it goes to servo 1 again. It goes to servo 2, to servo 2, servo 1, servo 2, servo 1, servo 1, servo 2, servo 2, servo 2, servo 1, servo 1. As you can see, what I did by doing this is it changes the randomness a little bit more. Instead of just servo 1 moving and then servo 2 moving, we're mixing it up. So it's not always, you know, just servo 1 moves and then 2. It'll be servo 1 moves, then there'll be a slight delay, then servo 1 moves again, then servo 2 will move, and so on and so on. I hope that makes sense to you. But we'll go up here quick and I'll go through the first one here. So what we're doing is we're setting the servo 1 position. So we're doing the random number and we're going for the servo 1 low and the servo 1 high. We want a number between those two numbers. And we're storing that in an integer of servo 1, S1, position, POS. And then what we're doing is we're writing that to servo 1. And then we're delaying, and actually we're selecting the delay, so it's DEL instead of DELAY. And we're doing a random and we're getting a number between the low and the high that we set again up above. And then we are implementing that delay. So what this does is, like I said, this makes it even more random than you could just do servo 1 and servo 2 and then get rid of the rest of this, but it's not going to be as random. All right. I hope that all makes sense to you. If you have any questions, please leave a comment. I will try to get back to you. Otherwise, I have some subscribers that will occasionally also reply to people's questions, because sometimes I don't always get notified, and sometimes I just don't have time at the moment to get to you. But please leave a comment if you have a question, and I will try to get back to you as soon as possible, or one of my subscribers will help me out and answer your question. And also remember, look in the description below. You'll find a link to this project's webpage where you can get a copy of this, and you can just copy it and paste it in your Arduino IDE, and there'll be pictures and any other information, a parts list, and all that, links to that Arduino Milanovi board as well. So all right, with that, please give us a thumbs up. I'd appreciate it big time. I hope you have a great day, and most importantly, and this is real important, very, very, very important, make sure you're always wearing your tinfoil hat, because we do not want the government and the men in black to know what we are up to.